Hi, this is Rob Yates, and welcome to Distance Learning Lesson 2. These are the lessons for Algebra 1 if your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McCrae, Mr. Strickland, Mr. Still, or Mr. Yates. If you have one of those teachers for your Algebra 1 class, then you're in the right space. Remember, you can stop this video at any time. You can rewind it. You can fast forward it. At the end, we'll have our joke of the day. Our learning target for today is I can determine if a table or a graph is linear or exponential. Having some problems with how this came through from the PowerPoint, but all that this says right here in the top is exponential equations are in the form of y equals a times b to the power of x, where a is your starting value and b is your multiplier. And down here it just says example. Can't see it because for some reason it's ghosted like the title above. And the example is y equals 3 times 2 to the power of x. 3 is the starting value. And 2 is the multiplier. If you look over here, we see a graph of y equals 3 times 2 to the power of x. The starter is 3, right there. That's 3. You multiply 3 times 2, and you get 6, right there at 1. And if you multiply 6 times 2, you get 12, which is what it would be at 2. Look at this table at the left. What is the starting value? All right, the starting value is always, what is y? That's supposed to say what is y when x equals 0. If we look over here, we can see it's 2. What is a multiplier? To determine a multiplier, I divide the second term by the first. So the second term would be 8 divided by 2, which is 4. And we try the next one just to make sure the pattern stays true and fits. 32 divided by 8, that equals 4 as well. So our multiplier is 4. So our equation is, again, y equals the starting value, or a, times b, the multiplier, or b to the power of x. Since our starting value is 2, it's y equals 2 times our multiplier, which we now know is 4 to the power of x. Is it exponential growth or decay? If the multiplier is greater than 1, it is growth. If it's less than 1, it's decay. You can also tell when it's growth, it goes up. As x increases, y increases. When it's decay, y will go down as x increases. Let's look at this table. What's the starting value? Again, what is y when x equals 0? If we look over here, we can see that it's 48. Well, ran right through it, didn't I? Sorry about that. All right. So, starting value is 48. What's the multiplier? We divide the second by the first. 12 divided by 48 equals 0.25. Does the pattern hold? What is 3 divided by 12? It's also 0.25. So our multiplier is 0.25. The equation is the starter times the multiplier to the power of x, so it's y equals 48 times 0.25 to the power of x. Is it growth or is it decay? It is decay, and how do we know? A couple ways. One way is multiplier is less than 1. The other way is we can see by looking at y that it goes down from 48 to 12 to 3 to 3/4. All right, it asks us to determine if each of these tables is linear or exponential. Here's what we need to remember. Linear adds same amount each time. Exponential multiplies same amount each time. So, if we look at the first table, 1 plus 1 is 2, but 2 plus 1 is 3, not 4. However, if 1, we look at it as a times, 2 divided by 1 is 2, 4 divided by 2 is 2, so 1 times 2 is 2, which times 2 is 4, times 2 is 8. So that means this is exponential because it's multiplying by the same number each time. Our multiplier is 2. Our starting value is whatever y is when x equals 0. So our starting value is 1. So our equation is y equals 1 times 2 to the power of x. Let's take a look at the next one. 1 times 3 is 3. 3 times 3 is 9, so that doesn't work. 1 plus 2 is 3, which plus 2 is 5, which plus 2 is 7. So it's adding the same amount each time, which means it is going to be linear. How much it increases or its slope is 2. So m equals 2. Starting value is whatever y is when x equals 0. So, the y-intercept is whatever y is when x equals 0. So b equals 1. Our equation is y equals 2x plus 1. How about this next one? 20 minus 10 is 0, 20 minus 10 is 10, minus 10 is 0, minus 10 again is negative 10. So it looks like it's going down by adding negative 10 each time. So that makes it linear. M equals negative 10. B is whatever y is when x equals 0. So B is 20. What is my y equals mx plus b equation? I plug in negative 10 for m, and I plug in 20 for b, and I get y equals negative 10x plus 20. Let's look at the last table. Starts out, when x is 0, y equals 20. That could be important. We'll have to see. Let's see, 20 minus 10 is 10, but 10 minus 10 is 0, so that doesn't work. But 20 divided by 2 or times 0.5 is 10, which times 0.5 is 5, which, yes, times 0.5 is 2.5. So it's multiplying by 1/2 or 0.5 each time, which means that it is exponential. The multiplier is 0.5. What's the starting value? What is y when x equals 0? If you said 20, you are correct. S equals 20. So, remember, it's y equals the starter times a multiplier to the power of x. I plug in 20 for s, and I plug in 0.5, or 1/2, for m, and I get y equals 20 times 0.5 to the power of x. All right, let's have a little summary. Linear equations have, it's y equals mx plus b, right? So they have an m, or a slope. And a y-intercept, or b. The pattern is to add. You add a constant number, the same number each time. You can add a positive or a negative number, but it has to be the same number each time. Exponentials have a starting value and a multiplier. The pattern is to multiply each time by the same number. But the multiplier can be less than 1 or greater than 1. If the multiplier is less than 1, or a fraction or a decimal, it's exponential decay. If it's greater than 1, then it is exponential growth. What's next? Go to Khan Academy and log in and do an exercise, or go to student.desmos.com and log in with your class code and get started on your first activity. You can try practice worksheet number 2 or Google homework number 2, and then watch the lesson 3 video. Remember, you've got reached the end of our lesson, so the joke for the day is a question. Can a kangaroo jump higher than the Empire State Building? Of course, the Empire State Building can't jump. We'll see you next time. Bye-bye.